BIM stands for Building Information Modeling, Model, or Management. It is a container term for all innovations related to the building industry's transition from a document-driven to a data-driven workflow. A BIM dataset consists of objects with relations and properties. A standardized open data format for BIM at the Industry Foundation Classes, or IFC. Within the Built2Spec project, BIM plays a major role in connecting the several quality checks to the rest of the data. Within Built2Spec, a virtual construction management platform, or VCMP, is developed to manage all data in a construction process and facilitate self-inspection and quality checking on-site. The VCMP has an object-oriented database that makes it possible to connect documents, tasks, or other information to objects in a BIM. This database is structured in the same way as the Open Data Standard IFC. There are many misconceptions about BIM and IFC. A BIM authoring tool has a central database that can be visualized as 2D, 3D, and table data. When several users, all with their own BIM authoring tool, collaborate in a project, it is often thought that the project should have a central database. Research and advanced practitioners have proven that this is not the case. Dynamically aggregating BIM objects for specific tasks is proven to be much more effective. The ambition within Built2Spec is to connect several different quality checking technologies to a central VCMP. Quality checking technologies used for indoor air quality, acoustic measurements, thermal imaging, air tightness, and point cloud comparison all have their specific tools and technologies. Within Built2Spec, the VCMP, therefore, is not trying to become a massive central tool that holds everything, but much more a hub that coordinates the connection between several tools and technologies. This is where we introduce the innovative approach of BIM bots to create a dynamic connection between a diverse set of technologies and services. Every quality check has a unique set of requirements from a BIM dataset, and every quality check will provide different types of results. Generically, the workflow looks like this. Within VCMP, an expert user starts a workflow for a new quality check. In this example, this is an air tightness test. The expert user sets up the requirements for the check. In this case, the user indicates the location where a test should take place. Data that are necessary for the check are being gathered from the IFC database in VCMP. In this air tightness example, the volume and the area of the room and the area of the building envelope are being queried and calculated. Now, a non-expert user performs the check on-site. All information that he needs is now provided by the VCMP. The result of the check is stored and the VCMP receives the result as well. In the example of the air tightness test in Built2Spec, the results are stored in a specific server and carbon copied to the VCMP. Authorized users can now view the results. If the quality check sends the result in a dedicated open data format for BIM issues, BIM collaboration format, or BCF, the results can be displayed in context of the 3D visualization of the BIM. During the implementation of the quality checks, the team encountered some major challenges related to the BIM data. We will highlight some in this video. For example, there is no standardized way to query or filter a BIM dataset. Therefore, it is almost impossible to get data needed for quality checks in an efficient way. The Built2Spec team, therefore, developed a new innovative BIM query and filter language based on the JSON format. This development is published as open source and available for all BIM developers. It lowers the threshold for developers to use BIM data in the object-oriented way it is meant to be used. Another example is the outer area of a building envelope that is needed for the air tightness test. This information is not explicitly described in the BIM data, so it had to be calculated from the data in the model. For this calculation, an innovative algorithm has been developed that uses novel triangulation approaches for geometry and uses semantics of the BIM data to handle small openings in the design. This algorithm is a patent-pending procedure at the moment because of its novelty. To make sure the data needed for specific quality checks are available in the BIM data, modeling guides and model view definitions have been created to facilitate this. Passive House Institute even created templates for major BIM authoring tools to facilitate users in creating high-quality data. A new approach was found to define model view definitions since the MVD XML standard was not capable of dealing with the detailed requirements from Built2Spec quality checks. As a final example, the tessellation of the IFC dataset has been optimized for the comparison between 3D point cloud data. The comparison between design of the building in BIM and the actual built situation represented in point cloud can now be compared, and results can be communicated in an object-based way. This is needed to facilitate object-oriented margin checks for errors. The final part of the Built2Spec workflow deals with feeding back the results to the VCMP. The BIM Collaboration Format, or BCF, provides a technology to communicate about BIM objects. The Built2Spec team experimented with BCF and found major challenges in the BCF interface to overcome. This brings major benefits to evaluate results from quality checks, and use that to analyze and predict issues on-site using self-learning algorithms. BCF will be further tested and evaluated in the Built2Spec project. The combination of BIM, the novel approach of BIM bots as a means of integration, and the use of BCF to communicate results all contribute to the data-driven approach of Built2Spec. Many other BIM innovations have been developed, applied, and tested. Most of them are published as open source and described in the associated deliverables.